The question says that a storage battery of EMF 8 volt and internal resistance of 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during charging, and what is the purpose of having a series resistor in the charging circuit? So this is the circuit diagram of this question. There is a battery of 120 volt which is acting as the source battery for charging the battery that is of 8 volt EMF. Now also there is a 15.5 ohm resistance through the battery, through the source battery in series, and the internal resistance of this 8 volt battery is 0.5 ohm. We have to calculate what is the terminal voltage of the battery during charging. That is, we have to calculate the voltage across this cell. Now we can run a loop and assume that anti-clockwise current is flowing in this circuit. I have assumed I to be in this direction. So let us proceed from this battery. So at point here we have 120 volt potential difference. So I have written 120 volt. Now at this point we can see that since the direction of current that is flowing is from left to right. So this point will be of high potential and this point will be of low potential. So we can write as 15.5 times AI. Now proceeding to this resistor, we will see again that in our assumed direction the current is flowing from right to left. So this will be the higher potential point. So we can write it as 0.5 times I. Now this is the lower potential, that is minus terminal of the battery. So we can write it as 8 volt, minus 8 volt. And now once we have passed this cell, we have reached this same wire over here that we have started. So it is, our loop is completed. Now we can write summation of all this equal to 0. So we will get a value of I as minus 7 ampere. That means our assumed direction of current was opposite. So a current of 7 ampere is flowing in this direction. Now once we have known the value of current in this circuit, so we can easily calculate potential difference across any of these components. Now this is the battery component, this is the charging battery component over which we have to find out the potential difference, terminal voltage of the battery. So voltage across this charging battery can be given by the potential difference across this component. So it would be equal to 8 volt plus, since the current is flowing in this direction, that is the clockwise direction from left to right. So this will be a point of higher potential now. So we can write it as plus 0.5 times the current. So 8 volt plus 7 times 0.5, that will give us a value of 11.5 volt. The question also asked, what is the purpose of having a series resistor in the charging circuit? The thing is, why do we use a series resistor in the charging circuit? The series resistor limits the current flowing through the circuit. Now without a resistor, the current would be very high due to the large voltage difference between the DC supply and the battery's EMF, potentially damaging the battery of the circuit. By controlling the charging current, the resistor helps in safe and steady charging of the battery, reducing the risk of overheating or overcharging. Thank you.